This is lesson 5. Oh no, I need my lapel mic on. I'm actually going to keep this in. Let's see all the hard work that I go. Alright, let's try that again. This is lesson 5, exercise 5F, applications of matrices. The learning goal for this one is to delve deeper into matrix multiplication and see it with another real-life example, and summing row and column matrices through matrix multiplication. The success criteria for this skill is to be able to confidently do matrix multiplication without the aid of the ClassPad calculator, and to know how to apply a 1 by n or an n by 1 matrix multiplication to sum a row or column within a matrix. Hopefully you guys survived the previous video of doing matrix multiplication and can confidently do the questions without any hassle. Now yes, your ClassPad calculator can help you out, but I really want you guys, especially with those doing further maths next year, to know the required skills to be able to do this. Now it is very algorithmic, and by algorithmic I mean there's just a simple process that you need to follow. And while the process does seem arbitrary and random and misleading because of the title, there are forms of multiplication within the process, but it's not all just multiplication. The steps that you have to apply are pretty much the same, no matter what type of matrix multiplication or the size or the order of the matrices that you're multiplying are. There's a bit of a tongue twister. So anyways, let's look at this example here, and we'll take Fatima and Gaia's store again. But on top of this, of selling DVDs and computer games, have now changed it from CD to computer games, they also have a sales promotion, a special sales promotion. One free cinema ticket is given with each DVD DVD purchase by a customer, and then 2 cinema tickets are given with the purchase of each computer game. So if a person comes into the store, buys a DVD, they're given 1 free ticket for the cinema for each DVD they buy, and then 2 free tickets for each computer game they buy. And realistically, this is not something that you see every day, but let's just take it for what it is for this example. So the number of DVDs and games sold by Fatima and Gaia are given within this matrix capital S, and the selling price of a DVD and a game together with the number of free tickets is given by matrix P. So $20 and $30 for DVDs and games for prices respectively, but also the amount of tickets given out for free for each of these categories. And what we're going to do is we're going to find the matrix product S and P, and then we're going to interpret what this information is. So to find SP, we're going to take Fatima and Gaia, I'll just put it as F and G, together with their DVD and their games, 7, 4, 5, and 6. And we're going to multiply this by the DVD and games together with the amount of money and ticket prices. Let's put T for ticket. 20, 30, 1, and 2. So remember, the process is as follows. Within the first matrix, you look at the first row, and within the second matrix, you look at the first column. Now, both of these are a 2 by 2 matrix. So this is a 2 by 2 and a 2 by 2. Because these two numbers are the same, it can be defined, and the resulting matrix will be, again, a 2 by 2. So I'm expecting a 2 by 2 size matrix with this result. So to get SP, we are going to get 7 multiplied by 20, and we're going to add 4 multiplied by 30. 4 multiplied by 30. So remember, I always just think of it as taking this chunk and attaching each number or each element within that row to each element within that column by multiplying each of the numbers and then adding them as I go along. In this case, that is what we need to work out for the first one. Now you'll notice that what we usually do in the previous example is then we go to the next row and apply the same process, but there's another column within the next matrix. So what we have to do is just take this row and then apply it again, but this time we're going to apply it to this column over here. So we're going to do 7 times 1 plus 4 times 2. And what this is saying is that we need to see how many tickets Fatima has given out based on 7 DVDs that have been sold and 4 games that have been sold. Remember, it's 2 lots for each game, so that's where the 4 times 2, and it's 1 lot of DVDs, so that's where the 7 times 1 comes from. So we've also got to consider the next column after the first column. Then the process starts again, but this time we're focusing on these numbers here. So there we have a 5 times 20 plus 6 times 30, 5, 20, 6, 30. And then again, 5 with a 1, so 5 by 1, added with a 6 by 2. And this here is our 2 by 2 matrix. We've got 2 columns and 2 rows. Obviously we need to work these numbers out, but what you should get is just 4 standalone numbers within the middle. All right. Let's use our mathematical skills to figure this one out. 7 times 20, 140. 4 times 30, 120. 7 times 1, 7. 4 times 2, 8. 5 times 2, 100. 6 times 30, 180. 5 times 1, 5. 6 times 2, 12. All right, let's add these 4 sets of numbers. 140 plus 120, 260. 7 plus 8, 15. 100 plus 180, 280. 5 plus 12, 17. Close that bracket. Now, the maths part to it is simple, but it's the context part to the question that a lot of students struggle, because they get to this answer here and then they say, wait a second, what number belongs to which category? How I know this, or how I know what I need to do, is generally speaking, whenever you get your first matrix and you look at the top context here, so the DVDs and games, and you match it up with the DVDs and games here, the top part of the first matrix and the left part, or sometimes right part, depending on where you write it, of the second matrix are the things that you ignore when writing the answer. Or in other words, the F and the G for Fatima and Gaia will go on the side. And in correspondence with this will be the top part of the second matrix, which is the $ and the amount of tickets. And all this just means is that, well, Fatima got $260 and had to give out 15 free tickets, where Gaia got $280 from her sales and sold 17 tickets, or gave out 17 tickets. What information is not given in here is how many games and how many DVDs that have been given out by each person. We do already know this from the previous set of information, the first matrix here, but when you get the results, the thing that we care about is how much money they got and the tickets that they gave out. So when we do our interpretation of this, all we would just need to say is Fatima obtained $260 and gave out 15 tickets, where Gaia obtained, you can use other words than obtain, I'm just using obtain because it's easy for me, obtained $280 and gave out 17 tickets. You can say a guy obtained, got, earned. It really depends on the context, but obtained is fine with me. This is the interpretation based on the results. Now, again, your calculator can go straight from A to B, or in this case, S and P straight to S times P. But it's this middle chunk skill that I want you guys to get confident with when it comes to the questions and the SAC. The next thing we'll be looking at is properties of row and column matrices. Now, the terminology can get a little bit confusing with the rules. So I'm not going to explain these rules word for word. I will relay back to it when I do the example. So row and column matrices provide efficient ways of extracting information from data stored in large matrices. So these matrices that we have here might look large in comparison to the previous work, but when we say large matrices, computers have the ability to store hundreds, thousands, even millions of digits within themselves. Without going on too much of a tangent, the way that televisions work are a bunch of pixels within your monitor. Those pixels are representing a certain color. That color has a code attached to it, which is provided within a matrix cell. As each pixel changes, the color changes accordingly to what the picture should be. And so sometimes it's interesting to see how by adding or subtracting or doing something to that matrix can affect the way that the TV can display something, especially within the color settings. Now that gets really deep into the science behind it. For now, let's just keep it to a minimum. In particular, when we do summing matrices, this can be used to sum the rows or the columns of a matrix. A summing matrix can be either row or column matrix where all the elements that we are multiplying by are 1. So what does that mean? What does it mean by just all of them being 1? Let's take this example here where there are 3 rangers and they've completed their monthly park surveys of feral animals. I don't like the word feral, it just seems like it's nobody loves the animals. So I'll just cross that word out, it's not feral, they're just lovable animals. And they've been cited, and the 4 of them are cats, dogs, foxes, and rabbits. And they've been put into this matrix, capital S. So there are 3 people, Aaron, Barra, and Chloe. And cats, dogs, foxes, and rabbits are represented by the C, D, F, and R up the top. Now on the side of this, we have 2 other matrices. We have a row matrix, which is full of 1s, and there are 3 ones specifically. And matrix B are 4 1s, which is a column of 4 1s. And it's specifically 3 and 4. The 3 across is to represent how many people there are, Aaron, Barra, and Chloe. And 4 down are to represent how many different types of animals there are, cats, dogs, foxes, and rabbits. I've got my dog, he just walked in. Hey, thanks. No, that's my lapel mic. Oh gosh, such a frazzly day. Get out of, let go of that. Drop it. Go on, get out of here. Tail's whacking into me. Go, get out of here. How'd you get in? Hold on guys. Alright, so I don't know if you've noticed, but there was a bit of a disconnect between that last part and now. I had to pause the recording. So I kind of forgot what I was talking about before, but as far as I'm aware with what was going on, oh yeah, that's right, the dog came in. Feral animal, I'm kidding. Alright, so we're going to evaluate S times B. So this matrix here multiplied by this column of 1s, and we're going to see what happens. So the first thing I'm going to do is I'm going to write A, B, C on the left, and small c, small d, small f, and small r on the top. That's talking about the people and the animals respectively. 27, 9, 34, 59, 18, 15, 10, 89, 35, 6, 46, 29 being multiplied by 1, 1, 1, 1. So what's going to happen is when we take this first row within the first matrix and multiply it by the first and only column within the second matrix, we're going to multiply each number by the associate number. So the first one with the first one, second one with the second one, and then add them all up. But the thing is, when we're multiplying by 1, we just get the same answer of what the initial number is in the first place. So this will be 27 times 1 plus 9 times 1. All we're doing is just really effectively adding every single number within the first row. So this will end up being 27 plus 9 plus 34 plus 59. Then we're going to do it again, but it's going to be with the second row. So it'll be 18 plus 15 plus 10 plus 89. And then again, third row, 35 plus 6 plus 46 plus 29. So when we sum this all up, we should just have 3 numbers that go down in a column. So I'm going to add it up, 129, 132, 116, and this belongs to A, B, and C. So what we just did was added up every single row for each A, B, and C, and all of that added up, what information about matrix S is given in the product of S by B? Well, this is just telling us how many animals all up each person observed, regardless of whether it's a feral or not feral, cat, dog, fox, or rabbit. That's how many animals. So the information, I'm just going to write info for short. The info from S by B tells us how many animals were observed by each ranger all up. So collectively, all up. So we're now going to do the same, but this time we're going to evaluate A by S. So it's not going to be S by A, because that won't work because of the order. We have to put A in front and continue with the matrix multiplication. Now remember, A has only got a row of ones, and there's only 3 of them. So when we apply this to it again, matrix S, so 27, 9, 34, 59, there we go. So what we're going to do is just get the first and only row and apply it to the first column, and then do it again, second column, again third column, and again fourth column. So what we should end up getting are 4 numbers that go across. So the first one is 27 plus 18 plus 35. So 27 plus 18 plus 35, because remember this will be 1 times 27, which is just the number itself, plus 1 times 18, which is again number itself, 1 times 35, again it's the number itself, and it's just going to be added to get the first element. Then we're going to do it again. Now just to make sure that you can see what's going on, I'll put a dotted line here. We're going to do it again. This will be 9 plus 15 plus 6, dotted line. Now I am running out of room, but ideally you would just put this within the 146, and then there will be another one that should go towards the end, and I'll just put it onto the side there. 59 plus 89 plus 29, close that bracket. So I answered for this one, which I'm going to just squeeze in here, squeeze it in here, we should get 4 numbers that go across. What you should get when summed up each 4 elements, 80, 30, 90, and 177 for cats, dogs, foxes, and up there, rabbits. So what does this info tell us? Well, this info tells us is how many observations were made for each animal, as opposed to each ranger. So what we have done is, in other words, if the question said, what is the sum of the first column and what does that tell us? That is essentially easy for us to do. We want to implement a matrix multiplication to get the sum of specific answers. So maybe we want to know how many observations were made for Barra. And we specifically wanted to see that information. This multiplication of a row or column of ones does it all in one hit. Just be careful of the order in which you do it. Because remember, you got to check your order to see where the row or column of ones need to go, whether it's before or after the matrix of context. All right, check your log sheet, see which questions you need to do for this exercise, and I will see you in the next video. Until then, bye-bye.